Assalamualaikum warahmatullahi wabarakatuh. My name is Noval Adriyan Firmansyah. I will be presenting about the application Internet of Things on SIM. Wait for loading. Take a few seconds.
There will be no time for us to fight with destiny. I will never change my mind to live a fact.
Presentation structure. First, there is the introduction. The second, there is the method. The third, there is the result. The fourth, there is the discussion. And the last, the fifth, there is the conclusion. Introduction. During the COVID-19 pandemic, hand hygiene is very important to reduce the risk of virus transmission. Physical contact on the sink can be a potential source of spreading virus and bacteria. To minimize the transmission of the COVID-19 virus, a tool is needed not to have direct physical contact with the sink faucet handle. That is an IOT based on sink tool. Method. In this IoT sink tool, the system is built using Arduino Wemos as the main controller. Two kinds of sensor are used for the sensor, namely an infrared sensor as an object detection sensor hand and an ultrasonic sensor as a detector for the availability of water and liquid soap. The system design is shown in the following system block diagram. The system block diagram image is an image of the system block diagram design. The system works by utilizing an infrared sensor which detects hand and an ultrasonic sensor is used to monitor the level of water and liquid soap in real time. Then the data is processed by Wemos. Wemos sends data to the database so that Link will read the data in real time and provide information to the OB via smartphone. How it works, we can see from figure number 1 how the IoT sync works, and we can see from figure number 2 system block diagram. Result. Table number 1. Based on table 1, the ultrasonic sensor detects object with a distance of 0 cm to 25 cm. It is marked that the sensor is not active at a distance of 0 cm to 2 cm and is measured using a ruler between the actual distance and the distance to the object, the hand. Experience an error range between 0% to with 15%. In testing the ultrasonic sensor using an arch, it is carried out to find out information on the detection of angles on the ultrasonic sensor, so that it can be seen from any angle the sensor can detect an object. For the direction of the angle of measurement, it starts from 0 degrees to 180 degrees, so that the sensor can detect object in the faucet path so that water can flow in the faucet path. The display of the tester image can be seen in figure number 5. Second result. Based on table 2, the test was carried out to determine the distance between the active and inactive sensor angle by using protractor and the 0 degrees point starting at the center point of the sensor. The object used is a pen to find out which angle is active. In this test, it is known that at an angle 10 degrees for 140 degrees, the condition of the sensor is active. This indicates the condition of the faucet is flowing and the pump is is running at an angle of 150 degrees for 180 degrees. The condition of the sensor is off and water does not flow to the faucet path. Testing the information on the level of soapy water in the blink is carried out to determine the suitability of the information displayed on the blink with the actual level of soapy water. The table for the level of soap water level with an automatic system can be seen in the following. Table 3. Low level of soapy water in smart sink prototype. Level water soap in centimeter. 14 for 8. This condition is available. The suffragette is flowing. At 9 for 1. This condition is almost gone and the suffragette is flowing. At 0, this condition is gone and this suffragette is not flowing. Table 4. Testing of liquid soap loudness information on blink. No. Number 1. Water level actually cm is 14. The information water level on cm 14. This condition is available. Faucet soap is flow. Result is feed. What at number 2, water level actually on cm. There's 13 information water level of cm is 13. This condition is available. Faucet soap is flow. Result is feed. Now number 3, water level actually on cm is 11. Information water level on cm is 11. Condition is available. Faucet soap is flow. Result is feed. For number 4, water level actually cm is 8. Information water level on cm is 8. Condition is almost equals. Faucet soap is flow. Result is feed. For number 6, water level actually on cm is 5 and information water level on cm is 5. This condition is almost equals. Faucet soap is no flow. Result no feed. For number 7, water level actually cm is 3. Information water level on cm is 3. This condition is equals. Faucet soap is no flow. Result is no feed. Discussion. The test was carried out on an Internet of Things based smartphone with the MQTT protocol. Liquid soap level testing on the Blink application runs well with real-time and accurate data. The reconnect function on the Blink app ensures a stable connection. The Blink application can connect to the broker without reconfiguring and can publish and subscribe on the same topic. Subsequent tests on ultrasonic sensor to measure the sensor error range in water containers saw an error range of 0% to 15%. The final test was carried out on faucet, which showed active angles from 0 to 140 degrees and off from 150 degrees to 180 degrees. Conclusion. Based on the result and discussion of the research that has been done, it can be concluded that 1. The ultrasonic faucet sensor has two active angles, namely an angle 0 degrees for 140 degrees and an inactive angles of 150 degrees for 180 degrees. The condition of the sensor will quickly respond to a hand object marked at the center angle of the sensor. 2. From the test result on the template, It is obtained that the average percentage value of the system error when running is 15% and the average percentage value for tool accuracy is 92%. The comparison of measuring distance using a ruler and an ultrasonic sensor has an error percentage of 0 cm for 3 cm. With a measurement distance of 25 cm, it can be concluded that the ultrasonic sensor can work with 92%. For monitoring of the shop, this in an Internet of Things basing was will using the Wemos D1R1 microcontroller and Blink as a real-time display of soap water level data. Monitoring of soapy water in the prototype sink can be accessed on a Blink application. That's all the percentage from me. Thank you.